Good afternoon, guys. I'll now make another video. This is about the Panamax vessel, and we are going to load bauxite in Australia and to be discharged in Japan. But we need a certain trim so that when we arrive in Japan, it will be even keel. So we have listed down the consumptions during the entire voyage, the fuel oil, diesel oil, and fresh water. So they will have a consumption amount of quantity to be discharged because of consumption, and when we arrive in Japan, it will be even keel. So this is a program especially made for that purpose. Okay, so let's start. Okay. This is now the problem or the situation. So we are going to load bauxite in Australia and it will be discharged in Japan. Okay, and the maximum draft of arrival in Japan will be 11 meters. And what will be meters at brackish water of a density of 1.012. So this is the density in Japan, and the density in the loading port of Australia is 1.010. Okay, and these are the items that being consumed during the entire voyage from Australia to Japan. So we have here the fuel oil number 5, center consumption of 261.6 metric tons, and fuel oil number 4, center 120.6 metric tons, and we have diesel oil consumption of in number 1, tank number 1, starboard, that will be 19.6 metric tons, and the freshwater consumption of port starboard will be 58.8 metric tons. Okay, so let's proceed. And this is the formula for required trim to depart Australia. So when we arrive in Japan, it will be even keel. So this is the formula for getting the exact trim in departure or in loading port. That will be displacement times LCG minus the LCB over MTC times 100. And to get the forward change of draft will be 1/2 LBP plus LCF over LBP multiplied by your departure trim. And to get the up change of draft will be trim minus the forward change of draft. Okay, so these are the required formulas in this problem. Okay, so we start now. So our destination will be Japan. So the maximum arrival drop there will be 11 meters, even keel. Okay, and the density in Japan will be 1.012. And what will be the displacement of this 11 meters? So we will check. 11 meters is 64223, and the LCB is negative 7.78. So take note of this displacement in LCB. We will put this in the problem. Okay, so here we are go. The displacement is 64223 and this LCF is negative 7.78. Okay, double check again. Here we are 64223 and negative 7.78. Okay, next, what will be the displacement if we have a density of 1.025, a density of 1.012? This is the formula, guys. So the displacement of 64223, which is this one, multiplied by 1.012, which is the density in Japan, over the constant of 1.025. And the value would, the displacement and 1.012 is 63408. We'll check, guys. That will be this one, 63408.464. Check again. 63408.08464. Okay. And this LCF, LCB, just put it down here to be as a LCG. So this will be your LCG, which is negative 7.78. Bring it down here, and LCG multiplied by your weight. This will be the longitudinal moment, which is this figure. Okay. Next, in number 6, we put now the consumable items. Take note, guys. We start from Japan, going down, going to Australia. So it's the reverse. So from Japan, you go down to Australia. So meaning to say, instead of consumption, you put this as negative, because consumption says plus and production means negative. Since you are going back to Australia, so it is positive plus. The consumption is plus. So you're going back to Australia. If you came from Australia going to Japan, then it will be negative. But in this case, it's the reverse. So from Japan, you go back to Australia. So you put back or load back the consumption. Okay. Here are the consumptions. Check. Here are the consumptions. These figures that I have stated a while ago, and these are the ones. Okay. And corresponding LCG, and this will be the longitudinal moments. And proceeding number 7, this will be the total displacement. You add this consumption with this displacement here, that will be a total of 63869.1. And you add all these longitudinal moments, and this will be your total longitudinal moments. This one divided by the displacement, or put it over, and this figure of longitudinal moment divided by displacement, and you will have the LCG of negative 7,257. Okay. So the next, number 8, what will be the displacement of 0.10 of the departure in Australia? So we will check the displacement if we have the density 1.010. The formula is the displacement this is the displacement here. Check. This is the displacement. It's F21. F21. This is displacement over times LC 1.025 over G23, which is this one, J23. Okay. So we use this displacement. So the displacement of 63869.1 multiplied by 1.025 over 1.010 in this density in Australia, this will be the value of the displacement is 64818. Okay, 64818 will be the density is 1.010. Okay, so we have, you apply here the density of 1.010, and this will be the value of displacement. Now, what is the corresponding draft of the 64818 metric tons? So we check this one. There's the table. This corresponding value is 64818. Well, this is almost 64818. The corresponding value will be 11.094 meters. So we will check. The corresponding value will be 11.094. This should be, and the LCG will be this one. So carry down the LCG here, and you still use this LCG, use negative 7257. What will be the LCB? What will be the LC value? So we go back to the interpolation. With this drop, the LCB will be negative 7.818. This one, negative 78.18. And what will be the NTC of this drop? Will be 925.1. So corresponding drop would be, MTC will be 925168. So 925168, which is this one. Sorry, 925.161. Just put 1, and the corresponding LCF of this drop of 11.094 will be, LCF will be 1.848, negative 1.848. Okay, that will be negative 1.848. This will be 148. Okay, so the next will be to get this, to apply the formula. Okay, we apply to, now we will apply this formula to get the departure trim. So we need a trim so that when we reach Japan, it will be even keel. So this is the formula to get the departure trim. Displacement times LCG minus LCB over MTC times 100, which is this one. So LCG minus LCB, which is LCG, which is this one, LCB in this one, this will be, the value will be 0.5561. That will be what we call the, that is what we call the, this is what we call the trimming arm. Okay, this one, 0.56 trimming arm. That will be the trimming arm, and multiply it by, that will be trimming arm, multiply it by the displacement of 64818, then you will have a trimming moment of 36362.9. Okay, that will be trimming moment. We have a trimming moment here. Check. No, we don't have a trimming moment, but this is the formula that we are using now. So we have not trimming moment, and then divide it by the FTC times 100. So the value of this one will be trimming moment. Okay, And once you have your trimming moment, you divide it by MTC, which is this one, and multiply by 100. And this is MTC, this one, 2925.1, multiply by 100, and the trim departure will be 0.393. 0.393. Okay, so that will be your final trim. 0.393, which is this one. Now, once you get this final trim or departure trim, you have to get your forward change of drop. The forward change of drop is LBP, your LBP, one half of your LBP, which is this one. One half LBP plus your LCF over LBP multiplied by your trim, departure trim. Okay, so meaning one half of your LBP, this is your LBP, one half of this is 1.07.5 plus your LCF, this is your LCF, negative 1.848, which is this one, over your LBP of 215 multiplied by your trim, total trim or departure trim, which is 0.393. Okay, this one, and the resultant of this one will be your forward change of drop will be 0.193. This will be your forward change of drop, 0.193. And to get the change of drop off, that will be your trim, departure trim of 0.393 minus your forward trim, change of trim, your up change of trim, change of drop will be 0.20, which is this one. So you apply this change of drop forward and up to your initial drop, which is 11.094, which is this one, with a density of 1.010 in your loading port. So you use this drop of 11.094 forward and up of 11.094. You apply the change of drop forward, which is 0.193, and up you apply the up drop, change of drop of 0.20, which is this one. So forward, you subtract this 0.193, so your departure drop will be 10.0901, and up drop, you add this change of drop up, and you will have a value of 11.294. Okay, so this is what we are finding out what would be our departure drop in Australia, and the trim will be 0.0393. So when we reach Japan, it will be Even Keel, and this will be the main drop of 11.0975. Okay, so these are manual computation. So we try to use the Excel. Okay, this is the Excel. So this will be the initial, this will be the arrival drop in Japan, and this will be the density. So a while ago, the displacement of 11 meters will be 64223, and we will have a LCB of negative 7.78. So when you apply this density with this drop, which is displacement, you will have a displacement of 63408 with this density 1.012, and this will be your, the LCG will be this one. So you bring this one down, and this will be your negative 7.78 will be your LCG. Multiply this one with your weight or the displacement, and you will have a longitudinal moment, which is this one. Then you put all your weights here or consumption, which is this one for number 4, fuel oil 4 and 5, and your diesel oil and your fresh water here. This will be your displacement at departure to upload port. So this will be your displacement at Australia, and this total of this one will be your total longitudinal moment. So this total longitudinal moment divided by your displacement, you will have a LCG of negative 7.25. Okay, 7.25. Okay. Then with this displacement, you apply the density at loading berth in Australia, and that the value with the density will be 64817. Okay, and that will be this one. The density of 641.1 times your constant of 1.025 over 1.01. This will be the displacement in the loading port. 64818. 64818 or 17. So with this displacement, you will have the value of draft of 11.094. So with this, the LCG here, you still maintain this one. You put the LCG here, and your LCB will be negative 7.818, which is this one, 11.094, and LCB will be negative 7.818. Okay. This one, 7.818, and your MTC will be 925.1. Your MTC, which is this one of your drop of 11.094, that will be 925.168. Okay, which is this one, 925.618, 925, how much? 925.168, 925.168. Okay, then your LCF will be negative 1848. Your LCF will be negative 1.848. Okay, so this one, and your how to get this trimming arm is this LCG minus your LCB. This will be your trimming arm, and this density trimming moment will be trimming arm times your displacement here. You will have trimming moments of 36442. 36442. We have 36442 here. 36442. This is trimming moment, and you will have a departure trim or required trim in discharging in loading in Australia will be 0.393. This one is 394, but you will have a trim of 0 0.3 3.93. This one, okay. And if you follow the same formula, your forward departure will be 10.90 and your up departure will be 11.29, which is this one, 11.90 or 10.90 and 11.29. Okay, 10.90 and 11.29, and your min drop will be 11.098, and your min drop here is 11.097.5 or 11.098. Okay, so this is manual computation here. This manual computation, and this will be by Excel. And this, remember guys, this is form number 7, form number 8, which is titled required trim or at departure to arrive Even Keel. So meaning your departure at loading port and to arrive in Japan will be Even Keel. This is program suited for this kind of solution. So that's it guys. If you like this video, please click the button like, share, and subscribe. Have a good day, and thanks for watching this video.